Hi everyone. In today's session, we will see eigenvalues and eigenvectors of the third category of problems. So the third category is non-symmetric matrices with repeated eigenvalues. So the matrix will be non-symmetric, but the eigenvalues will be repeated. This is the third category of problem. So when you observe the question, find the eigenvalues and eigenvectors of 2, minus 2, 2, 1, 1, 1, 1, 3, minus 1. So the matrix so when I observe this matrix, this is a non-symmetric matrix. See, the first row is 2, minus 2, 2, but the first column is 2, 1, 1. So it is a non-symmetric matrix. So S1, to find the characteristic equation, the same formula we will apply. S1 is nothing but sum of diagonal elements. So I get 2, 1, minus 1. So S1 is 2. And S2 is sum of minus of diagonal elements. So when you fix up the diagonal elements and when you write the minus, you get it as 1, 1, 3, minus 1 plus determinant of 2, 2, 1, minus 1 plus 2, minus 2, 1, 1. When you expand this, you get S2 value as minus 4. Then to find out S3 is nothing but determinant of A. So determinant of A is nothing but 2 minus 2, 2, 1, 1, 1, 1, 3 minus 1. I'm going to expand along the first row. So I get 2 times 1, 1, 3 minus 1, minus of minus 2 times 1, 1, 1 minus 1 plus 2 times 1, 1, 1, 3. So when I just do the arithmetic calculations, I get S3 value as minus 8. So I know the characteristic equation of a 3 by 3 matrix is lambda cube minus S1 lambda squared plus S2 lambda minus S3 equal to 0. So when I substitute, the characteristic equation of the given matrix becomes lambda cube minus 2 lambda squared minus 4 lambda plus 8 equal to 0. Now to find the eigenvalues, see, this is an equation of degree 3. So I'm using this method. 1 minus 2 minus 4 8. I will write the coefficients of all this, and just by trial and error method I'm choosing. When I put lambda equal to 2, so here I have to add up. 1 plus 0 is 1. Here I have to multiply. 2 into 1 becomes 2. Here I have to add up 0. 2 into 0 is 0. When I add up, I get minus 4 minus 8. So this remainder I have to get 0. This is how we do the method, and using the remaining terms as coefficients, we will fix up the next two values. So this will corresponds to lambda squared, this corresponds to lambda, and this corresponds to constant. So this is lambda squared plus 0 lambda minus 4 equal to 0. So I get lambda squared minus 4 equal to 0. So lambda squared equal to 4. So lambda is nothing but plus or minus 2. So now what are the eigenvalues? So one eigenvalue is here lambda equal to 2, and the remaining two values are 2 comma minus 2. So here when I observe, the eigenvalues are repeated. So this is what we are going to see the difference. So here the eigenvalues 2 is repeated. So to find out the eigenvector, first I will choose the non-repeated eigenvalue lambda equal to minus 2. So a minus lambda I into x equal to 0. When I put lambda as minus 2, I get a plus 2i into x equal to 0. When I do a plus 2i, I get the matrix as 4 minus 3 2 1 3 1 1 3 1 times x1 x2 x3 equal to 0. When I want to solve this, as in the previous video which we have seen, the previous category, I will choose the last two rows, but here I won't choose the last two rows because the last two rows values are same. So let me choose the first two rows. Okay, the first two rows. So this is x1 x2 x3. So x1 by it is minus 2 2 3 1, and x2 it is 4 1, and x3 it is minus 2 3. So x1 by it is minus 2 minus 6, which is equal to x2 by 2 minus 4, x3 by 12 minus of minus 2. When I simplify, the first eigenvector x1 is 4 1 minus 7, corresponding to the eigenvalue lambda equal to minus 2. Next, I will take the next eigenvalue lambda equal to 2. So a minus lambda I into x equal to 0. So when I put lambda value as 2, the matrix will become 0 minus 2 2, 1 minus 1 1, 1 3 minus 3 times x1 x2 x3 equal to 0. Here I can choose the first two rows or last two rows, whatever may be I can choose, because all the three rows are different. The same methodology when I take, I get x1 divided by minus 2 plus 2, x2 divided by 2 minus 0, x3 divided by 0 plus 2. So x1 by 0, x2 by 2, x3 by 2. So the second vector is x2 is nothing but 0 1 1. So the third eigenvalue is also lambda equal to 2. So there is nothing we have to do with the same equation with lambda. So we will get the same matrix here. So when you choose first two rows, For finding out the next eigenvector, you choose the last two rows. When I choose the last two rows, I get x1 divided by, it is 3 minus 3, and x2 divided by 1 plus 3, and x3 divided by 3 plus 1. So I get x3 as 0, 1, 1. So this is how we find out eigenvalue and eigenvector of a non-symmetric matrix with repeated eigenvalues. Thank you.